This lesson is for Advanced Algebra, Lesson 1-7 on equivalent formulas. When students are working with equivalent formulas, it's basically the same process as solving equations, only it's working with more letters than numbers. Students need to remember to work backwards and move stuff that's farther away from the variable first. I usually indicate the variable that we're going to be working with as with an arrow to kind of anchor it in place, and then everything else needs to move away. One of the other things that happens in the lesson is the book starts to incorporate a particular kind of language about how equations are organized. So in this particular example of d equals rt, we would say that the variable d is given in terms of the variables r and t. So it's just a way of indicating which variable is all alone or isolated on one side and which variables are on the other side. So if one variable is given in terms of the other, it means that first variable mentioned is the one that's being isolated. So what they're going to do is give you an equation, and they're going to say solve for one of those variables. So in this case, the r is going to stay put. That means the t, in this case, needs to go to the other side. So the r stays, the t has to move. The t is being multiplied by the r, so to undo it, we would have to divide by t on both sides. There is no way to simplify d divided by t unless they had given us some values. So the d over the t just stays the way it is, and now the r is isolated. Now the equation has been rearranged, and now r is given in terms of d and t. And so that's the basic idea of this lesson. We're going to look at a few more examples. In the next example, we have the formula a equals 1/2 b times h. It's a formula for area of a triangle. They want us to solve for h. So the h is going to stay put, the b and the half have to go away. In this first method, we're going to leave the h and move the 1/2 and the b in separate steps. Since the half is further away from the h than the b is, we're going to move the half away first. Half is being multiplied, and to get rid of a fraction, you always multiply by the reciprocal. So I'm going to multiply by 2 or 2 over 1 to both sides. The half and the 2 are going to cancel or make a 1, leaving me with b and h on one side, 2a on the other. Now that the h is going to stay, I need to get rid of the b. So to get rid of the b, I have to divide on both sides. So I'm going to divide both sides by b. What that allows me to do is cancel out the b values. And on the other side, the b is on the bottom, and 2a remains on the top. So now h is given in terms of 2a and b. Another way to handle that same question to solve for h is to handle the b and the h together. Since they're both being multiplied, you can simply handle those like a single fraction and get the answer accomplished in a single step. So I'm going to multiply both sides by the 2 to get rid of the half, and then I'm going to divide by b. So that step can happen simultaneously because I'm basically multiplying by a fraction on both sides. So I'm going to multiply both sides by 2 over b. The 2 over the b times the a on this side, I can turn that a into a fraction. So the 2 times the a is on the top, b times 1 is on the bottom, and then I'm finished. So know that students can handle things separately like we did in the first example, or if they want to, they can combine steps when there's multiplication involved and multiply simply by the reciprocal. The next example is a little bit more involved. There's more happening in the equation. There's more steps to handle, so I want to show students how to maneuver when there's a lot more going on. This time we're going to solve for n, and n is on the inside of a set of parentheses, and typically that can lend itself to being a little bit more complicated for students. So the n has to stay. The thing that's the furthest away from the n is the a, so we're going to get rid of the a first. The a is being added, so we're going to subtract it to move it. The a now moves to the other side. We can't simplify t and a together, so it simply becomes t minus a. The n minus 1 is still in parentheses, and the d is next to it. The d has to move next, so it's being multiplied because it's right next to a set of parentheses, so we're going to divide to get rid of it. Again, we can't do much over on this side, so we just rewrite what we have. Keep in mind that the d gets divided by both of these, so we have to make sure that our fraction bar covers that. Now that the d is gone, we no longer need parentheses on this side. If students do include them by mistake, it's not wrong. It's just that they're not needed. Now the 1 has to move because we're trying to, again, get the n alone, so we'd simply add the opposite to both sides. Keep in mind here that the plus 1 can either go at the beginning. Typically you want to do things from left to right, however, so it's probably more appropriate for that plus 1 to go to the right of the fraction. Keep in mind that that whole fraction gets added to the 1, so you want to make sure not to incorporate it just on the top, but as a separate piece entirely from the entire fraction. So we want it to be very much separate from the a or the d or the t. One final example here is to solve this for x. And the difficulty on this problem is the thing that we're trying to solve for is in the denominator. I want to remind students that you cannot solve for x when it's in a denominator. So your first step here is to simply move the x to a new location. Since the fraction bar here works like a grouping symbol, as we learned earlier in the chapter, the x and the 33 must travel together for now. So the x and the 33, if we need to move that to the top, we're just going to simply multiply it on both sides. Now the x that we're going to be solving for is over here, because the x's that we were working with on this side, the x plus the 33 divided by itself, those pieces are going to cancel each other out. So now we have x plus 33 in parentheses on this side, the x is going to stay, and we want to move the t and the 33. So we're going to move the t first by dividing on both sides, then we're going to get the x alone by adding the opposite, and we end up with our answer. And I think I neglected to circle our final answer on that one, so let's go ahead and circle that. Again, watch out there for the adding the opposite step that is separate from the fraction. Two other things for students to consider. If there is a subscript, like there is on this one says v sub o, that subscript is going to travel with the variable as you're trying to solve. So don't get worried about what to do with that. It's simply a label that's going to move with the variable. Just know that it's not a separate step. And then just a reminder here for students, how do you get rid of a square? If you're trying to undo a square on something, you would use a square root.